Here's a real quick introduction to log-log graphing. Let's graph y equals x on the log-log graph paper that I provided you. And I'm going to simulate that on the computer here. So here's the log-log graph paper. And it's got it written as 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. On the log-log graph paper that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 2, 3, 4, 5, 6, 7, 8, 10, 2, 3. It just repeats. What you're going to need to do first is actually just change that. Let's start from 1, 2, 3 up to 10, so don't change those. And then just put an extra 0. This is 20, 30, 40, 50, up to 100, and then 200, 300, 400, all the way up to 1,000. And similarly on the x scale, it's going to be 1 through 10, then 10 through 100, then 100 through 1,000. And so that's going to be how you want to plot things. So if you're going to plot y equals x, for example, then here's 2 points. Here's 1, 1, 10, 10, 100, 100, 1,000, 1,000. That's not too hard. And then just, hey, that's interesting. It's a straight line. Well, that's not too surprising for y equals x. But we'll see there are some surprises in store for log-log graphing. What about something more complicated? This is an example I'm not having you do, so this is a little bit different. 1,000 over x. Well, let's just plot the same 4 x values. 1, 10, 100, 1,000. So at x equals 1, y is going to be 1,000. Okay. At x equals 10, y is going to be 100. 1,000 over 10 is going to be 100. That's plotted right here. At x equals 100, y is going to be 10, because 1,000 over 100 is 10. And at x equals 1,000, 1,000 over 1,000 is 1. That's interesting. If you graph this function on regular graph paper, that is not, those points are not going to line up to be a straight line. But in this case, they do line up to be a straight line. So that's interesting, and you'll see some other similar behavior when you graph the other couple of functions I want you to graph on your own.